In problem 1, we want to find the limit of this function. Here's a picture of it. What's the limit of this function as x gets really close to a? So as x approaches a from both sides, what is the function approaching? Now the function, of course, the function values are on the verticals. So as the horizontal values get really close to a, what are these verticals approaching? So let's start here. Let's come in from the left side. I'll draw it over here. You can see we're approaching a from the left side, and as we come up this curve, say from the left, I'll draw it here, I'm approaching from the left. It looks like vertically we're coming up this way and getting closer and closer to this number p. So as we approach x, as we approach a from the left side here, as we come in from the left side, the verticals of the function seems to be approaching this number p. So I'm going to write as x approaches a from the left side, this function seems to be approaching p. And now as we come in from the right side, let's have our horizontals come in toward a from the right side, and I'll trace along the curve. It looks like our verticals are approaching that same number p, right? As we get closer and closer to a from the right side, the verticals are getting closer and closer to that number p. So I'm going to write at the limit as x approaches a from the right side of f of x, that's also equal to p. And because as we come in from the left side and the right side, these two values are equal, we're going to say that that's our limit. So we're going to conclude then that the limit as x approaches a of f of x is equal to p. Now in problem number 2, again we want the limit of this function as x approaches a. So down here in our picture, here's a, and you can see just visually as you come in from the left side, the horizontals come in from the left side, the verticals seem to be approaching p, right? As you come down this curve approaching a from the left, the verticals seem to be coming down approaching p. And likewise, as you approach from the right side, you're traveling down this curve, getting closer and closer to that point p. So I'm going to conclude here then that the limit of this function here, the limit as x approaches a of f of x, that is p. Now here in problem 3, we've got two parts. We want, first of all, what happens as we approach 10? What's the limit of the function as we approach 10? That is, as x gets closer and closer to 10 down here, what are the function values getting close to? Now remember, the function values are the vertical values. All right, so as we're coming in, just imagine yourself really close to 10 here from both sides. Well, as you're from the left side, as you come in from the left side, it's like you're traveling down this curve and you're getting closer and closer to 6, right? You're descending towards 6. Now, we don't get to 10, right? We're just approaching 10. This whole idea here of that arrow is we're approaching 10. So it doesn't matter what happens when we get there. We just want to know what happens as we approach. And as we come in this way here, as we're moving along the curve to the from the left, the verticals are descending towards 6. And as we come in from the right, the verticals are approaching, right? They're ascending toward 6 again. So we're going to say that because when we're ever really close to 10, the verticals are really close to 6. So we're going to claim now that this limit here is 6. And in part B, we want the limit as we approach 3. So look over here at 3, and you can see that as you're really close to 3 here, these function values, right, the curve, both sides of the curve are really close to 4. So as we get closer and closer to 3, the function values, the verticals, get closer and closer to 4. So we'll say that this limit is 4. In problem number 4, we want again, in part A, the limit as we're approaching 3. So let's locate 3 down here. Now, as we approach 3 from both sides, imagine yourself on the curve. Say from the left side, you're declining, you're traveling along the curve and you're descending toward what number? Looks like 8. And then as you're on the right side, right, approach from the right side, as you're traveling along the curve, you're ascending toward what number? It looks like 8. Now remember, we don't care what happens at 3. This whole idea with the arrow is we're approaching 3. We don't care what happens when we get there. When we get there, it goes blank, but as we are approaching from either side, we're getting closer and closer to 8. So as we're really close to 3, the function values are close to 8, so we're going to claim that that's 8. And in part B, we want to know what is the limit of this function as we approach 6. So here's 6 down here. Oh, now look what happens here. We've got a break in this curve. As we come in from the left side, imagine yourself on the curve, coming in from the left. We're descending toward what number? Toward 5, right? As we're coming down this curve, we're getting closer and closer to 5. That's from the left. So in this case, the limit as x approaches 6 from the left side, that is 5. And then as we approach from the right side, so here you are coming in from the right, you're on this curve, traveling along the curve from the right, and you're descending toward what number? The closer and closer you get here to 6, you're descending toward 7. All right, so it looks like as we come in from the right, we're approaching 7. So I'll write that like this. The limit as x approaches 6 from the right side of f of x, that's equal to 7. And these two numbers are not equal, so we're going to say that this limit, I'll put it in here, does not exist. There is no limit here, because as you come in from the left, you're approaching 5. As you come in from the right, you're approaching 7. So as you get closer and closer to 6, you're not approaching any one particular number. So we'll just describe that by saying the limit does not exist.